of this presentation today is more about how better we design our product and the way we control our manufacturing processes, right? So the agenda, why electronics, right? Why we're talking electronics and why not other things? I got some market potential data, which will tell you about the trends that how the business into automotive electronics is growing worldwide, and also the market cap of automotive electronics. What is the headroom available right now for automotive electronics? And then why we are talking about design and manufacturing? Why it is important? Some challenges and failure, those are generic, but these are all very common failures into electronics. And then overcoming, how will come overcome from these situations. Okay, why electronics? So if you think like from last maybe 50 years or 80 years, so every innovation that we are doing today is because of the electronics. Every year you have some controls that involve some level of hardware as well as software, and they goes along with your embedded systems or controls or electronics. So that's why I would say this is the need of an hour, and also like we've been using from last many centuries that we are doing innovation, and that is all across the electronics. We talked about a lot of other things today. If you think about automotive, so we are talking about automotive today. So if you see a normal ICE vehicle or any electric vehicle, there has multiple components that goes with electronics. Let's talk about IC, right? So you got body control module, you got ECUs, you got different lamps, and then you talk about EV, right? You got TMS system, you got battery management system, you got DC-DC, you got charger. So there are a lot of things that uses power electronics, and the key thing that how this thing's gonna work, right? So we talk about ADAS. So let's say we implemented ADAS and we got ADAS level 5, right? So when I see like ADAS level 5, driver or the person who is driving the car does not need a mind. He can just keep quiet, sleeping in the car, or maybe the car will drive automatically. In case if the controller which is driving your car will not work, what will happen? So that's why it becomes more important that how better we design our product and to make sure that how the quality parameters are performed and the testings and qualifications is made up. So that's why it's become more important rather designing a product and also making sure the quality parameters. So right now, how many of you own electric vehicle? Can you raise your hand? Okay. I would say maybe even less than 1%, or maybe like let's say 1%, right? Why we are still thinking to buy an electric car? Why don't we simply go and like there are a lot of things that we talk today, right? From the morning that EVs are really good for future, or I think those are cost effective, those are really good for environmental things, you would save a lot of fuel and other things, right? But one thing that I see, and that's a challenge always, is the component maturity. We think like we have charge anxiety. We also have some anxiety that something will fail, right? Because it's completely electric vehicle, and also in the industry, people don't have much knowledge about these components and also the systems. So we are worried, right? We have some anxiety. And how we can overcome from this is because we don't have right level of maturity of the reliability of those components. And many organizations are still working on those and they are evolving day by day, right? Now, one of the things like the market potential, right? So if I talk about the global automotive electronics market from ranging last 10 years, like maybe 2022 to 2032. So it is predicted like 2050 billion US billion dollar to $650 billion on the CAGR of 10%. So we are growing drastically, maybe next 10 years, and maybe it's underrated, I'll tell you. We would still have more potential because there's a lot of things happening all across the country and also all across the world on automotive electronics as well as other electronics projects. It's not only about automotive, but if you see India now, how electronic industries has evolved in the last 10 years. So I think that makes more sense when we think about this data and also invest a lot in electronics and focus on this technology. So this is one of the data which talk about the different distribution in design, like what areas of system we have in our vehicle. Let's say you got power electronics, you got safety controls, you got communication and entertainment in your vehicle, and then body electronics. Now you see the numbers, these are all in $1 billion. So body electronics reaching from 0.9 to 2.8 in from 2022 to 2030. And then communication and entertainment will reach from 1 billion, approx 1 billion to $10 billion. The biggest thing that we are concerned, and I think that is going to be deployed, and I think you see the change here, the safety controls, right? It could be ADAS or maybe the traction control or the ABS, whatever controls we are going to have in future. I think there is significant growth, right? So we are reaching from 4.4 billion to 26 billion dollar. I think that is significant, right? And also for electronics, which is mostly used for EVs, like the inverter, converter, DC-DC, PDUs, all different components. So there's a lot of headroom and also the scope available for electronics. So the important thing now, so we got a lot of scope. There's a good headroom up that we will be growing, and also we would be investing a lot in electronics. But how to basically think about creating a quality product, right? That is most important. We keep investing, we keep evolving, but what and how we'll do it, right? So today we're talking about design and manufacturing. So if I like quote about quality, so whatever products we have, even a cell phone, right, uses electronics. We always concern about the quality. Whenever you start buying nowadays, I think we come a long way in cell phone or the mobile manufacturing, where you have good confidence that the phone will work for sure. You never think you buy a phone, whatever phone you want to buy, you'll buy a phone and then you will just okay, that will work for sure. Maybe like 1 or 2% of the companies would still have some issues in your phone, but 90% or so companies would give you good performance because of the maturity, right? And there is a lot of work in design, right? So quality comes from design as well as manufacturing. So that's why I think we're focusing more on design and manufacturing today for electronics. Now, like what are the challenges we have, right? So we are talking about automotive, right? So I just researched some of the thing and I keep talking. The major issues that we have right now and we have been seeing in the industries like safety and compliances, right? Could be a failure for ADAS system that you're supposed to do, maybe lane departure or like cruise control. I'm sure we are not using in India. We still need some more time to develop those infrastructures, and then yeah, even we have cars, but yeah, infrastructure I'll tell you. But what thing come in your mind, like if something goes wrong, your control is not working, definitely it's a safety and compliance issue. Additionally, I tell you like product failures. A lot of failures you would see in product all across the world. A lot of recalls happens because of some or other way. Those are related to hardware or software, right? Those are electronics again. Performance issues, right? We talked about today like the battery aging. I would tell you it's completely the way we design our product. You can predict your battery life. So cell aging is one of the concerns, and basically it gets generated by the way that you charge or discharge your batteries, right? So how better we define our algorithm, right? When you talk about battery management system, the controller for the battery management system or the battery pack, how better you define the algorithm? Let's say you switch off your vehicle when it's 90% charged, right? And don't overcharge your vehicle when it's like in the high temperature conditions, or the conditioning should be fine, like your temperature should go down and then start charging. So those kind of controls we can invite into the BMS or the battery management system. So to further enhance the quality of the battery and the cell aging because of the users inside the heat conditions or overcharging even after the 100% charge. Thermal management system, I think this is one of the biggest problem in EVs right now, that the conditioning is not happening right, and the vehicles are catching fire, there are issues happening all across the world, right? One thing, right, how better algorithms have been defined. If you do some of the research on those input, you'll find there's always issues, on the control side. The controls were not made appropriately, and hence it went up to out of the control limits, or maybe the boundary conditions, and then vehicle got got fired. So I think those kind of issues, and then obviously for EVs you will see you're connecting your vehicle but it's not charging, right? These are some of the common failure, and the last thing is how reliably we think of our component in design, right? And these all things can be controlled through design, as we talked about, right? The better we design our product. But also, when we think about the scope of, let's say, the embedded systems of these all controllers, these are made of like hardware plus software, right? Alone, hardware will not work, I'm sure. If you see, let's say, the power supply, that also needs some kind of software that is inbuilt into the chip or the component that you're buying, right? So for electronics, when we work for, let's say, a normal EV, look into EVs or simple IC vehicle, you might have 150 or ECUs, right? Or maybe more in case of NS level 5 car. So you got hardware and software. Now one more thing, right? The maturity. How you will think of the components maturity and those systems that they will work fine. So one of the things that is always important is we think about the maturity from design as well as manufacturing perspective. How mature you are in terms of your design when you do qualifications, and how mature you are in your manufacturing processes, right? What kind of automation you have, what kind of control you have to detect and prevent this failure or issues before going into the customer hand, right? So as today we're focusing on, let's focus like how we can basically completely qualify our design, right? So definitely we have a lot of processes when we design our product, a lot of protocols, how we would like test our product, the different scenarios, standards. Still, we have a failure, right? So some of the things which is not looked into, which is electronics manufacturing process. Now, when I say electronics manufacturing, so you did a great design. Today, a lot of companies they're still using some of the old technology, like they're using through-hole component, manual sorting, wave sorting processes. Those are probably like 50 years old processes. So how we can overcome, right? So first thing is about the requirements gap. How better we define our requirements, how better we use our tools to write requirement, like use systems engineering approach, right? How you can define those things in your document when you work with any of the supplier to develop component or OEMs, right? Refer industry standards, right? What is required and how it should be tested, not only for design but also for manufacturing. Then how it is going to be used, right? The application, right? That's very important in the environmental conditions. We talk about the battery. The biggest factor for battery to perform well, and also about the synergy, and also to give the performance is the temperature, right? In any polyphonics component or any electronic component, I think temperature is kind of enemy. If it goes up, it will definitely fail your component for sure for electronics. And then design and qualification. So again, for design, there are a lot of industry standard. I want to refer to you from IPC. It's a body which defines a lot of electronics design as well as manufacturing process standards, where you will find like standard for inspection, handling, maybe rework and repair. A lot of standards that you can refer. One more thing I would like to mention here, which is the design and the modular design. So we are still using a lot of conventional design way where you have wire directly soldered. I'm not sure I'm talking, which is something out of the scope right now, but if you see the electronic process, you have some wire coming out of the controller, right? Anything which is used inside the car, you have wiring harnesses. Now those wire goes to the controller, and even some of the companies are still soldering those wire onto the board. It means you have to do some work, and there's a manual intervention required, or the process required to be continuously monitored. And you find issues in those processes for sure because the design are not good. And also, if you see, when I say modular design, you have like onboard mounted connector. Again, there's a cost factor, but you can mount those connectors, just plug and play, like connect with a wiring harness, and you can use, and then you can better improve your performance of the vehicle and also quality of your vehicle. And a lot of vibration issues, because if you use our car for a period of time, you would have some issues that probably you can prevent with simple modular design when you work with your supplier. And also like through-hole component, I mean the component to be inserted on the board and do some kind of wave soldering or manual soldering, where the persons are sitting on the bench and doing soldering. That is still the practice. I think we should not be doing that, and we should completely drop it off. We should try to focus, if we can probably go on maybe 99 or 95% of the coverage. And then last thing is about the manufacturing use of some of the assembly standards, and then assembly standards, and then avoid wave soldering machines, and then maybe use some level of 3D SPA. We're talking about Omron, or I think Emron. So this is solder paste inspections, which prevent some kind of issues, and there are some standards and audits that we could probably adopt. So I think this is something which we can barely focus, but there are a lot of other issues we left. Software maybe a different topic to talk in other conference, but hardware, if you focus, I think this will reduce maybe 40 to 50% of the issues. Additionally, there will be some more issues from design, or even component itself has failed, like the chip is failing or having some kind of issues. You got counterfeit part, a lot of duplication happened in COVID. So those kind of issues and scenarios could possibly happen. So I think these are the things if we can focus.
My question is like addressing the elephant in the room. We talked about hardware. So within hardware, there are 3 or 4 aspects, like how you select the power side, how you select the layout of the board, how you select the power side. Now it talks to the embedded system, and overall, in a system level, how it interacts with the multiple devices which is in the predominantly the automotive industry has been mechanical focused. So there are moving parts. People understand that. How do you see a transition from a mechanical industry to a large electronic industry? And what are your thoughts on that? So any insights would help.
I think that's a very good question, and the only thing is about how fast we adopt this technology. Like shifting from mechanical to electronics is a big leap, and this is not today. Maybe it started maybe 30, 40 years back. The only thing is about the maturity today. It is already there. So whatever things we talk today, everything has control and embedded, like hardware and software together. The only thing is the maturity. That's what I'm talking today. So the evaluation has already happened. The invention is already happening. They're already using. Even the cell phones are like come to any level where today you got everything. It's like kind of computer itself, right? You can do everything. The only thing is how better we define the reliability and the requirements, and then make sure of processes. So on the transition side and the evolution, I don't see any challenge, and I think it's happening very well. And thanks to government of India, also they're promoting a lot of local manufacturing in India on electronics now, and there are a lot of companies investing into these kind of advanced automotive technology for electronics manufacturing. So this is what I would think today.